at firm level, we are not only interested in finding out the profit level of a certain firm. Instead, we can also be interested in finding out the rate of growth of the profit, because this is another important aspect that can give us some insight into the dynamics of profit over time. So let us see that how we can calculate this rate of growth of profit over time. So if we are given a certain profit function of a firm, we can note this, and in this case it is specifically this function in which the time variable is appearing in a cube root in the exponent. So we can write it in this form, which is the power form of the cube root, that is the power equal to 1 over 3. After this, we can see that time variable is in the exponent. So if we can bring it down to the foundation or the base, it will be good for us. So in order to get rid of this exponent and to bring down the time variable in the base, as well as to be able to find out the growth rate of the profit, which is based on the derivative of the natural log, we can take the natural log of this function. So here we are going to take the natural log, and then we will get this answer, which is definitely under the laws of logarithm. And you can see that natural log is taken separately of this coefficient and then of this term. So now we can simplify it. We know that we can come up with some numerical value of it, and the natural log and e is cancelled out here, and we have got this exponent in the base now, and now t variable is in the base, which is good for us to be able to use t variable for calculation. So if I write the answer of this term, it will be derivative over the function. So this is the derivative and this is the function. So I'm going to write this here. You can see in a different way it is written, and the natural log of this term is also mentioned here. It is not visible because it is 0, and then this term, when we differentiated it, the power, that is 1 over 3, came in the beginning. The 1.2 term was there, and the power of this variable reduced to this, and the answer would be minus 2 over 3 of t. This would be 0.4. So we have rearranged it and written it like this. You can pause the video and see this simple calculation, and this derivative is actually helping us to find out the overall value. However, there is another small step is there, that is pi is shifted on the other side here, because we are interested in the derivative term only, because we can use this term to calculate the rate of growth. So after taking this derivative, we are in a position to substitute the derivative term here and write the profit function as it is in the denominator. So this is the value of the derivative term, and profit function is not written in detail here because we can see that this pi can be cancelled out with that pi. So we'll be left with this term only, and this is the growth rate of the profit function, which is dependent upon time. As you can see, it is based upon time. Now just to see the ability of this function, or this growth rate function, to guide us about the certain level of growth in the profit after for example 8 years or 8 points in time, we can calculate it by substituting t is equal to 8 and then solving it. So we got 10%. This is the growth rate after the passage of 7 years and during the 8th year. So the profit shall grow at 10% if 8 years are allowed to pass. So in this way, this growth rate function that we developed is capable of guiding us about the growth rate of profit at a certain point in time or after a certain point in time. Thank you.